We are going to go ahead and take a look at Unit 2, Day 8, or Day 2.8. We are just talking about graphing systems of linear inequalities. Last lesson, we looked at graphing individual linear inequalities, and then a few lessons before that, we had talked about graphing systems of equations. Guys, all this really means is we're going to put two graphs on the same graph. We're going to put two inequalities, rather, on the same graph. There's two boundary lines, two shaded regions, and we're going to look where the shaded regions overlap. And so here's kind of our process for doing this. We're going to graph the first boundary line and shade that solution set, meaning shade above or below. Then we're going to graph the second one and shade above or below. And then we're going to kind of double shade or shade the overlapping region darker. Okay, that double shaded region is going to be our solution. And so I'm going to kind of show you how to do that as we go through with this. Now we're going to start off, all of our inequality systems are going to be in slope-intercept form already. So I can just use a couple different colors here for the overlap. But we're going to start just doing one inequality at a time. So there's not a whole lot of new content for this lesson. We're just doing kind of double duty. We are graphing both inequalities on the same axis. So for this one, we're going to start with our y-intercept first, which is -2. So for this first inequality, I'm going to go to -2 on my y-axis. Then I'm going to go down 6 to the right 7. So from -2, I go down 6 to -8, and I go to the right 7. Okay? I could do the same thing. I could go up 6 to the left 7. And I end up along that same path. So I'm going to take a straight edge, and before I make my line, I want to go back and double check that this is a dotted line because it is just greater than. So I'm going to line up my points and just graph a dotted line. Okay? And now since I am looking at a greater than symbol in slope-intercept form, I'm going to shade values above the line. Okay, I'm going to shade above that dotted line. And I'm not actually going to shade in a whole lot. I'm kind of just lightly putting in some lines there because it's not my final answer. There's more to be shaded from this other line. So I'm going to look at my y-intercept of this line now. That's -7. I'm going to go down here to -7 and put a point. And then I'm going to look at that slope, which is down 1 to the right 7. So down 1 to the right 7 puts me right there, or up 1 to the left 7 puts me there. This is also going to be a dotted line. So I'm going to graph that dotted line along there. And I'm going to shade below that line. Okay? So when I shade below this line, there doesn't look like there's much of an overlap, but what you notice down here in this corner is where it's both above the blue line and below the red line. That is my overlapping region. Okay? And so I'm actually going to come in with another color. You don't have to. We can just shade this, and this is the solution set for that system of inequalities because it's the region where both of these inequalities are true. And that's all you have to do. So we're going to try another example. All right? In example 2, we've got two inequalities. This one looks normal. This is our slope-intercept form. But the first one, remember, is one of our special cases. Okay? This is an x equals or x greater than or equal to -5. Remember, any inequality or equation that looks like this, where there's only an x, not a y, and there is a constant number over here, this is a vertical line. And so we're going to mark -5 on the x-axis. Okay, we're going to go to the x-axis and mark -5. And that's a vertical line, and it is or equal to, so it's a solid vertical line. Probably should have used my straight edge, but that's good enough for our purposes there. And I want to shade values bigger than -5, so that means I'm going to the right. Okay? So I'm just going to kind of lightly shade that one. And now I can move on to graphing the other boundary line. The y-intercept here, because this is in slope-intercept form, this will be diagonal. The y-intercept is positive 2, and we're going to use a slope of up 3 over 5. So from there I go up 1, 2, 3 over 5. 1, 2, 3, 4, 5. And I could do that again, 1, 2, 3, 1, 2, 3, 4, 5. Or I could go the opposite direction, down 3 over 5. Any way I go about that, I want to line those up. And when I line them up, I want to remember that this should be a dotted line. Okay? I just said dotted, then I drew a solid. Let me fix that. Just a little bit of whiteout tape, and that'll fix that. So a dotted line, and since it's greater than, we want to shade above. So I'm going to shade above that dotted line. And wherever my shading overlaps now, that region here is actually my solution set for the entire system of inequalities. So I'm going to double shade that so that I know that's my solution. Okay? So we're going to do one more example, then I'll let you try and do some of these on your own. Okay? We're actually going to come down and do example 4 together, and then you can come back and try example 3 on your own in a minute, but we're going to do example 4. In our first inequality, we have y is greater than or equal to 4/7 x plus 4. So my y-intercept is 4, so that's where I start, on the y-axis at 4. And then my slope tells me to go up 4 to the right 7. So I'm going to go up 1, 2, 3, 4, to the right 1, 2, 3, 4, 5, 6, 7. When I line those up, you'll notice this is a solid line. Okay? And because I'm shading above, because it's the greater than or equal to, I'm going to shade this side of the line. Okay? Now I'm going to graph my other line. Less than or y is less than 4/7 x plus 5. This time I have a y-intercept of 5. And I'm going to go again, up 4 to the right 7. So 1, 2, 3, 4 to the right 7. These lines actually have the same slope, but this line should be a dotted line. This graph is going to be a little tricky to read because everything's so close together. But when you graph these inequalities and they end up having the same slope, all right, but with shading, sometimes it doesn't mean there's no solution. When we graph regular lines and they have the same slope, we would say no solution because they don't cross. But this time I'm going to shade below my dotted line, and that means that I'm actually overlapping this tiny sliver right through here. And so that is my solution, that tiny little band between the lines, and I don't even have to finish shading the rest, as long as you clearly mark that as your overlap. Okay? So what I want you to do, I want you to try examples 3 and 5 on your own. Try those and bring those to class. If you can bring those at least with an attempt made, then again we will have a little bit shorter assignment if you can show me that you watched the video and taken notes.